Donc, la présentation d'aujourd'hui est en anglais, mais vous pouvez choisir de l'écouter en français en utilisant le bouton Simultaneous Interpretation qui se trouve en bas de votre écran, donc c'est au milieu. Vous aurez donc l'option de choisir entre l'anglais ou le français dans ce menu-là. So today's session will be in English. If you prefer to listen in French, you can click on the Simultaneous Interpretation button at the bottom of your screen, and then you can choose French or English in the menu that opens up. So please note that today's session is being recorded and that the recordings will be available on FCM website. So on behalf of FCM, I would like to begin this session by acknowledging that we are on land that have been inhabited by Indigenous people for thousands of years, and that we at FCM, we recognize the Algonquin Anishinaabe people as the traditional custodians of the lands upon which FCM's office are located, and where I am myself currently situated. So we also recognize the contributions of Métis, Inuit, and all First Nations, both in shaping and strengthening this community and our country as a whole. So wherever you are today, please join me in paying our respects to the original stewards of this land and committing ourselves to thoughts and action that will lead to meaningful reconciliation. So if you feel comfortable doing so, I encourage you to add your own acknowledgement in the chat. And if you're looking to learn a bit more about Indigenous land or unsure of which land you are currently located in, we're going to post a link in the chat to a website created by Native Land Digital. And it maps out traditional territories, languages, and treaties of Indigenous people around the world. So quite an interesting website. Now maybe before we dive in, just a few housekeeping items to get through. So each of our presenters has prepared a 15-minute presentation to share with you today. So we're going to run through each presentation, one after the other, and use our remaining time for discussion and Q&A at the end. So just for your awareness, I will use a sound signal as a time reminder for our speakers. So if you hear a noise, don't worry. It's not that I've forgotten to turn off my alarm. It's just for giving time. So you are welcome to ask questions through the chat box during the presentation in the language of your choice. Apologies. We will keep an eye out for any clarification question or other key items that we should address before the Q&A session at the end. So that's also if you have any technical inquiry. I know that we're all used to webinar and online meetings at this point, but just a reminder to please keep your microphone muted and close your camera during the presentations. This will help ensure that there are no disruptions to our presenters. Finalement, un dernier petit rappel que si vous souhaitez écouter la présentation en français, vous devez sélectionner le bouton Simultaneous Interpretation en bas de votre écran. Donc, vous allez pouvoir choisir l'option français. So today the topic of our presentation is community buildings. And this webinar will address how building recommissioning can help municipalities improve their community buildings' air quality for safer reopening, while also making these facilities more energy efficient. So my name is Emilie Marleau, and I am an outreach advisor here at FCM, and I have the pleasure of being your moderator today. So to give you an idea, I will start off with a brief introduction, and then I'll transition over to our speakers. So as you know, the Federation of Canadian Municipalities, or FCM, is the national voice of local governments in Canada. FCM's mandate includes delivering programs that build municipalities' capacity to do what they do best, so deliver innovative, cost-effective local solution to environmental challenges and to enhance quality of life for their residents. This mandate is directly related to the mission of our largest funding program, the Green Municipal Fund, or GMF. So GMF has a double mandate to support municipal initiatives in sustainable development through funding and share knowledge and lessons learned through online resources, tools, training like our event today, as well as peer learning and networking activities. So over the past 20 years, GMF has supported initiatives centered on waste, water, energy, land use, and transportation under what we typically refer to as our core funding program. So in addition of this core funding, GMF's mandate also grew in 2019 to include 4 new initiatives. So the community efficiency financing, sustainable affordable housing, community buildings retrofit, and the low carbon cities Canada. all of which aim to achieve significant GHG reductions at the local level. If we can switch slide, please. So today's webinar will obviously be focusing on the Community Buildings Retrofit Initiative, which we just launched in last April. So during the webinar, we will address the following questions. What is building recommissioning and why is it important? Why include building recommissioning in the retrofits of a community facility? How building recommissioning can be a tool to include sustainability in your asset management plans? And how can municipalities work toward preventing indoor disease transmission while also implementing cost-saving energy efficient solutions? So to answer this question, we are very pleased today to have a fantastic panel. Please join me in welcoming Ian Meredith from NRCan, who is Program Development Officer at the Office of Energy Efficiency. Anastasia Lukianova, who is the Sustainability Planner for the City of Powell River in British Columbia. Seaman, who is the Director of Sustainability and Asset Management Director for the City of Markham in Ontario. And Meg Sears, who is a Senior Research Associate at the Ottawa Hospital Research Institute. So once again, thank you all for joining us today. And Ian, I will now hand the floor over to you.
Great. Okay, merci beaucoup, Emily, and hello everybody, and welcome to the webinar. Just going to bring up my, okay, here we go. Okay, so again, thanks, and merci, Emily, and hello, welcome to all, et tout le monde. Just to let our Francophone viewers know, my presentation will be on Anglais, but the slide deck will be made available to you en français when our FCM organizers send out the post-webinar package to you. So my job today is to basically take you through a commissioning 101, explain there we go. Explain to you what commissioning is, and specifically what existing building commissioning is all about, and as was mentioned a moment ago, why you should care about commissioning, why all of us governments should care, and particularly municipal governments should care, and what you should be doing about it. I'll be telling you about some stuff that NRCan has been doing over the years to promote the uptake of existing building commissioning in alignment with the kind of general purpose of this webinar. I'll be touching a little bit on EBCx and its relation to post-COVID recovery, and then telling you about a national programming framework that we've kind of spearheaded the development of, and again with the cooperation of municipalities. So to begin, what is commissioning? As it says here, it's basically a quality management process to help ensure that the building systems and equipment are operating as intended. But why does this even exist? Why was it developed? Well, to be quite blunt and quite frank, because over the last several decades, far too many buildings have been constructed and operated in a way that was not matching their design intent, not efficiently, not effectively. So this profession, this commissioning profession, kind of evolved to meet this market need of making sure that buildings were in fact operating the way they were supposed to be. So we can talk about both new and existing building commissioning. So in the case of new buildings, again, it's kind of this quality control aspect of it, where a commissioning professional will oversee and work with the entire building production team, from the architect to the mechanical designers to the general contractor, the crews, right through to train the operators, with the idea of making sure that the new building will actually be built, constructed, and operated according to the original intent of the designers. And this is extremely important and has numerous benefits to everybody concerned, not just the people who make the building, but the people who occupy and use the building eventually. In the case of existing building commissioning, you can think of it more as a tune-up, where we're applying the same kind of quality control processes, but the commissioning professional will come in and help to restore the building to its original design intent, or perhaps to respond to a new intent that's evolved from changing use of the building or whatever. In either case, it's important to understand that this is very different from retrofits. When we think about improving a building, we usually think about, oh, well, let's change this and change that. And indeed, the program this is kind of attached to is a retrofit program for municipal recreational facilities. But sometimes the answer isn't to replace stuff. The answer is to take what's already there and make sure that it's working as well as it can, and bring it back to its optimum performance. And that's the important point about commissioning, that it's a low cost, no cost alternative to those retrofits, or in some cases a complement to a retrofit project. And if you think a tune-up isn't important, I don't think any of us ever buy a new car and don't think of bringing it back to the dealer from time to time to get it tuned up. You'd be amazed at how many building owners will invest millions and millions of dollars in a new building and then never get it tuned up. They just assume that the operations crew are going to continue to operate it, in a perfect manner over the years. And that just doesn't happen. Even when you have the best operating crew in the world, things drift, control sequences get out of whack, conditions around the building change and so on. So this idea of an existing building commissioning tune-up is an extremely important thing. And then for you as facility managers, very, very important to think about this from time to time, no matter how diligent you think you are being about your own operations. Before I leave new building commissioning, I want to touch on one thing that really is important for you as municipal stakeholders. As you may know, the federal government spearheads the development of building codes, just both the general building code and specifically the National Energy Building Code for buildings. We develop a model code. The provinces and territories choose to adopt it or not. Typically they do, or at least adapt it into their building codes. But it's up to you. It's up to you, municipal officials, to actually enforce those codes and make them come to reality. But again, the best design intent in the world, and by extension, the intent of building codes, can only be realized if the building is actually built and built properly and run properly. And again, there's where commissioning comes in. Now turning back to existing building commissioning, which is again the real purpose of this presentation. I just want to take a minute to talk about the three types of commissioning, or the three kinds of terminology you might hear. The most common term you probably hear is recommissioning. Well, this emphasizes the fact that commissioning isn't a one-time thing. You commission a new building and you come back from time to time and you recommission it. And again, that's the term you most commonly hear, but it really applies to a building that has been commissioned in the first place and is committed to this, cycle of recommissioning from time to time. You may also hear the term retro commissioning, and sometimes you'll hear those used interchangeably by people, and that's not quite correct because it is a distinct type of commissioning. And this applies in the case of a building that has never been commissioned, or perhaps wasn't commissioned properly when it was built. And the qualitative difference here is that the commissioning practitioner who comes in to do the job will have a much more detailed, much more comprehensive investigation stage to really understand what's going on in the building and what needs to happen. If the building has been recommissioned on a regular basis, those records are probably already there. And you have an emerging concept of ongoing commissioning, which typically, but doesn't always, include the use of some kind of technology or a software package that will go on top of your building automation system, for example, to help the operations crew basically commission the building on an ongoing basis. It signals them as soon as things are going out of whack and they can go and deal with them. So again, this slide is kind of give you a bit of a different picture about the process. The graphic on the left sort of, again, emphasizes that there's a very cyclical nature to this. You as operation, or you as facility managers, need to assess your status from time to time. Understand that, okay, now it's time to do a commissioning project. So, the commissioning starts, you monitor things, you do functional testing, Any number of commissioning professionals that I know will tell me it's almost like a five senses kind of approach. You're not just looking at a meter or, or walking around the building looking at things that don't look right, but they listen, they feel, feel for vibrations, they even smell, like an odor or a sound that shouldn't be there, that's there, or maybe that should be there, that's not there. All those things tell the commissioning practitioner, what's going on in the building. And based on all of that, they make improvements, for, control sequence adjustments, inclusion of monitoring steps that aren't being done right now, maybe sensors that could be included that aren't there now. Again, all low cost, no cost stuff to optimize the building operations. These are implemented. And again, you monitor after the fact to make sure that you've achieved what you want to do, and it goes around and around. On the right, we see the emphasis, that the very important emphasis, that this is a team approach. And you may not, you can choose to even do your own commissioning, although typically it's best done when you bring in a third-party professional to do it. But that whoever, that commissioning person can't work in a vacuum. They need the support of you as facility managers on top to identify the need for the project and to facilitate it and support it. You have the commissioning professional themselves, and underneath that, they can't work without the cooperation of building operators, who again need to be appropriately trained in the operation of the building, which is a very important associated issue. So all those working together to make a commissioning project happen. But why do we care? Why does this federal government guy sitting here talking to you about commissioning, wanting you to care about this? Why does any government, including federal or municipal governments, care about commissioning? Well, there's lots of reasons. And for the Office of Energy Efficiency, where I work, obviously we want buildings to be efficient and save greenhouse gas emissions. And the better commissioned a building is, the better it runs, the better it performs, the more energy it saves, the less greenhouse gas emissions it'll create. But that's just one reason. We realize that building owners and managers will commission for a number of other reasons. They just want the building to work well. They want the occupants to be healthy and happy and productive and safe. Job creation, not just creating jobs for commissioning people, but improving the skill sets of your operators is as I said, an important side issue that goes with this. I mentioned a few minutes ago the relation to commissioning about, to you municipal officials in terms of code compliance. These are all really important reasons to commission. And I think one of the most important ones that we overlook, that I emphasize at the bottom here, as governments at all levels, the market, the private sector, they look to us for leadership. They say, why should we bother commissioning our buildings if you people aren't? So there's another reason to be invested in it. And that's an important word back, by the way, before I leave that comment. A lot of people talk about, oh, commissioning it's a cost. It's something else I have to spend money on. No, commissioning is an investment. It's an investment that you are making in a better building. And in order to help you make that investment, NRCan has invested a lot of our own money over the years developing all sorts of tools and products. So we have guidebooks to help you. We've developed training courses. We don't deliver the training courses anymore. The two I mentioned here are developed by put on by the Canadian Energy Training Institute. We've done case studies, we've developed various tools, we participate with the CSA, for example, in standards development. And these are all things that we're doing to try to, get Canadian stakeholders to better understand what commissioning is and to do it well. And one in particular, I was going to mention that, again, you'll be getting links to all those things when our FCM friends send out the post-webinar package. The one I wanted to touch on that kind of touches on part of the point of this webinar today is our HVAC assessment tool that we developed. And we developed this in response to the COVID pandemic, and understanding that as buildings start coming back on stream, including the recreational facilities that many of you in this webinar today are managing, you'll be looking at sort of new and improved operating regimes. You want to make extra sure that the air that's being distributed around the facility is safe and healthy. And that probably will require more energy, but this checklist of 10 best practices will help you do that in a way that will still maintain your optimum energy efficiency. And of course, one of those best practices that's promoted in this tool is commissioning and commissioning aspects and doing a commissioning project in general. So I hope you'll use this tool. I hope you'll understand while you're using it, its connection to commissioning, and see the value there. So besides all those tools and courses and things we're developing over the years, we've been paying attention to the market. We've been doing a lot of research into the market, or paying attention to other people's research into the market. Not to belabor this slide too much, but note on the bottom, the most recent thing we did was work with our FCM host today to do a survey of municipal officials. And the overwhelming conclusion of all that research we've done is people aren't getting it. There's just a lack of awareness, a lack of understanding about what commissioning is. People aren't understanding the value of it. Even though despite all the great things I've said about it, there's just not a significant market uptake. So we realized that we need to keep pushing this and keep making people aware. And I want to again emphasize that lack of awareness, I'm afraid, extend into your municipal sector. We found that out very clearly when we did that last research project. That lack of awareness and understanding is there with you folks as well. And we want to help you increase your awareness and understanding, which is why people like me come and do webinars like this. So how do we collectively move forward? Well, we recognize from that research there was this need, to increase awareness and understanding, and to make sure that everybody is sort of rowing in the same direction. There's a lot of stakeholder organizations involved in this. It's not just up to the federal government to tell people to commission their buildings and how to do it. There's the commissioning industry themselves. There's the building owners themselves. There's all levels of government. There's utilities. All these different stakeholder organizations have a role to play, and and it's getting everybody kind of working together, having the same conversation, talking about commissioning in the same way. So we came together. We formed 2 years ago. We formed this working group, this national working group, to work on this tuning up framework for existing building commissioning, which again it will we feel will help this situation. And I won't belabor the process and so on too much, but just to, again, emphasize from the slide that the municipal end was very highly involved in this. We had 5 municipalities who actively participated on the development of this, along with the FCM themselves. So what is this framework we came up with? Well, it's basically 5 integrated pillars that inform policy and program development. We have creating awareness and a common understanding, building capacity, expanding the evidence base, identifying tools and developing tools, and then integrating all those things into programs and policies. And I hope you can see from that that's obviously a very integrated thing. You can't just do one or two of these things. You need to kind of coordinate all those things together. And our description of these pillars includes a goal, barriers and challenges to achieving that goal, key actions that can overcome those barriers, and other resources. And that'll be coming out probably later this month. The work on it is done. We're just waiting final approvals, and we expect to have that framework produced or actually out in the public viewing, like I say, within a month or so. And again, this was a team effort to produce this framework, and commissioning itself is a team effort. Everybody needs to be involved in promoting this important activity. And it recognizes, again, I talked about governments, utilities, the owners, the commissioning people themselves, and each one of those groups has their own perspectives, their own motivations, their own strengths and resources they can bring to the table, the challenges and constraints they have into achieving one thing or the other. So this is why we all have to work together. And that includes you municipal folks, and I hope I've been able to teach you something a little bit about commissioning today, and look forward to any questions you might have later on. So thank you very much.
Thank you very much, Ian. That was very insightful, and definitely we are keeping some time in the question period for anyone who might have questions. Feel free to write them in the chat as well, and we will keep track. So we'll be moving already to our next speaker, Anastasia Lukianova, who is a sustainability planner for the city of Powell River in British Columbia.
Hello, everyone. Can you see my slide okay?
Yes, we see it. Thank you.
Excellent. Thank you very much. And yeah, thanks for joining the webinar. So today I'd like to share with you our experience with building recommissioning, but actually more broadly, what we've done with our recreation complex here in Powell River. We're a small community up on the Sunshine Coast of British Columbia, about 15,000 people. So I'll talk about various initiatives we've implemented at our rec complex and how the recommissioning fit into that. So when I started with the city back a couple of years ago, the first thing we did is we took an inventory of our corporate carbon footprint. So we looked at all our buildings, fleet, equipment, and basically did the carbon accounting to see what are the emissions, where they're coming from, and where are our biggest opportunities to reduce. So as you can see on the slide here, our total corporate footprint, about 1,900 tons of carbon dioxide equivalent. And we will subtract what the total cost is of those carbon emitting activities. So those would be our electricity bills, natural gas bills, and our fuel. And that's $1.6 million. So fairly significant, small community like ours, and definitely opportunity there to not only cut the carbon, but also cut our bills as well and save. And if we look at how those emissions break down by source, in BC here, we are fortunate with primarily hydropower. So electricity is a small portion of that footprint, but it is significant in terms of costs. So we don't overlook it when we look at energy reduction. And the rest of our footprint is split evenly between gas, natural gas in our buildings, and fuel in our vehicles and equipment. And when we dig a little bit deeper, we see that our recreation complex is a big source of emissions, primarily natural gas. It accounts for about 1/3 of our corporate footprint. So it's quite a significant emission source, and that's where we looked for opportunities to reduce first. So a little bit about our complex. It's a fairly large facility built in the 70s. Over 140,000 square feet. It's got an aquatic center, pool, weight room, fitness studio. It also includes a fairly large theater with 720 seats, 2 NHL-sized ice surfaces, so 2 ice arenas, multiple meeting rooms. That's a fairly large facility that we have here in Powell River. And if we look at our utility costs, so this is our baseline 2017, our electricity bill for the year is over 200,000, natural gas over 100,000. So definitely opportunity to reduce carbon, but also cut costs as well. And here you'll see that, even though electricity is a fairly small carbon footprint, but the costs are significant. So again, we look at reducing both natural gas and electricity. So first I'll talk about some of the low-hanging fruit initiatives that we implemented when we just started making efforts to reduce energy at our complex. So the first thing we did was we completed a full LED lighting retrofit. These are some of the before and after pictures of our complex. So with that initiative, not only did we see energy savings, but it also just really improved the aesthetics of the complex for our users, and staff noticed big improvement as well with lighting levels. And when we implement initiatives, we always look at the business case. So in this case, for the lighting, our simple payback was just over 8 years, but we always focus on a different metric, not just the simple payback, but the IRR, or internal rate of return. And in this case, this is 13%. So that's really the metric that we focus on when we talk to our city council and communicate with the public about these investments in energy efficiency, because we feel that's a much better metric that reflects the benefits that we're seeing from this work, not just the simple payback. So that was one of our first initiatives. We also installed a low emissivity ceiling. This one was motivated primarily by the need to maintain the ceiling. Our old foam insulation was actually starting to come off, so we needed to do something about it. And this low emissivity ceiling kind of doubled as a building renovation, but also energy efficiency initiative. We've also installed realized system. So as some of you may know, folks who work with ice sheets and Zambonis, typically Zamboni is filled with hot water. And the reason for it is you want to get rid of the small air bubbles in the water to flood the ice. Of course, that means gas use to heat that water. So with this system, the water spins through this vortex piece, and it basically gets rid of the air bubbles without the need to use hot water. So those are some of the low-hanging fruit initiatives we've implemented when we started. And then we had the opportunity with our gas utility for this BC to do a thermal energy study. So to do a more holistic, take a more of a holistic look at our building and see what are some of the initiatives that we can implement to really cut down on energy use and the carbon footprint. And this is a bit of a detailed table, but the summary of it is they really offered us 3 initiatives to implement to reduce emissions. The first one was a heating system upgrade. It's basically a boiler replacement. We were due to replace our boiler anyway, and there was actually a plan to do a 1-to-1 replacement, but we're really happy we did the study just in time because it proposed a much better option for our boiler, a much more efficient option, and we only had to look at the incremental cost of that better option, and the payback was quite good. The second option, the second initiative their study recommended is DDC optimization, or direct digital controls optimization, which really is recommissioning. So what this is not really replacing any capital equipment, it's just looking at our controls that we already have, updating some settings for ventilation, temperature control, and also adding a couple more controls where there aren't any at this time. And you'll see that that initiative is really where the payback is so quick, 0.6 years. It's low cost for us, just under $15,000 compared to the other ones, and a rate of return of 175%. So that study really showed us that the recommissioning is where we will get the biggest, by far the biggest return on our investment in energy efficiency. And the third initiative is the heat recovery. And that one has quite the long payback of 28 years, 1.3% rate of return. But that's the one that delivers the deepest reductions in our gas use. So when we look at the building holistically like this, and we look at the package of those measures, what that allows us to do is to look at the overall payback and return on investment, instead of kind of picking initiatives that are particularly high return. We can look at them as a package, and what that does is it gives us both a good financial case to implement it, but also deep carbon reductions. And so what are some of the things we've done so far with the study? We did move forward on that first recommendation with the boiler upgrade. We just did it in March this year, received the support from our gas utility for this BC of $150,000. So we're already seeing some savings from that. And our next step is to implement that commissioning recommendation from the study. So here in BC, our utility, electric utility, BC Hydro, offers support for continuous optimization or building recommissioning. And we've received about $20,000 to have an engineering consultant prepare detailed specifications of what exactly needs to be done to recommission the building, what settings needs to be updated, what sensors need to be added. So we have completed this work, and we are now at the stage where we're ready to implement those recommendations. So we're just getting quotes from contractors to make those changes. And we are excited to see how that's going to further reduce our energy costs and emissions. And so far, even though the boiler update was just done in March of this year, so we haven't even had a full year with our major retrofit, we're already seeing quite a dramatic reduction in energy use. So here you see the comparison between the 2017 baseline for electricity and gas and the last 12 months. So that's up until today of energy use. So you can see there's quite a substantial reduction that we're seeing, and that's with the new boiler not even haven't been in place for a full year yet. So what are some of the key lessons for us from the work we've done so far? I think in getting buy-in for this initiative from our council and management is really focusing on the business case and looking at the rate of return, not just a simple payback. Also bundling the project to maximize emissions impact. Sometimes we found that initiatives with a really strong financial case may not have the largest carbon benefit if they have to do, say, with electricity reduction. But if we sort of bundle them with others that focus more on the gas use and present it as one package, then we can have both. We can have the GHG reduction and a strong business case as well. And with the work we've done, as you've seen with this thermal energy study, for us, building recommissioning definitely has by far the strongest business case of all the things we've done. So we're excited to implement those measures soon. Utility incentives have been helpful for us. We, in BC, our utilities, BC Hydro, Fortis, have quite a few programs where they supported us in the work that we've done. And last but not least, consultant relationship with a company that's really gotten to know our building has been really critical to us being able to do this work, because as a small community, we don't have the highly technical staff that's able to dive into those initiatives and implement those very technical projects. So having that ongoing relationship with a consulting firm that's focused on energy efficiency has really been key to being able to implement those initiatives. And those are the highlights for us from Powell River. And thank you very much for your time, and I look forward to questions at the end.
Thank you very much, Anastasia. Thank you for sharing Powell River experience with recommissioning, and also to give us the perspective from a smaller municipality as well. So that's quite inspiring. We're continuing along, people. We're moving now to our next speaker, Seaman, who is the Director of Sustainability and Asset Management for the City of Markham in Ontario. Over to you, Graham.
Thank you, and good afternoon, everyone. Thanks for the opportunity to present. Let me make sure I got my full screen going. Okay, are we good? Everybody can see it? I'll take that as a yes. Okay, so thanks for the opportunity. We're a medium-sized municipality. We have about 360,000 residents. We have the objective that was endorsed by our council in 2018 for net zero emissions by 2050. Three guiding principles will get us there: decreasing overall local energy consumption, switch to low carbon renewable sources, and increasing local energy generation from renewable sources. This applies to our entire city, and our entire city emissions were about 1.8 million tons of GHG emissions in 2011, which is our baseline. So it's a broad plan, and it also applies to, so this is the community. I think we all know that this type of nomenclature. This is our community emissions, which includes our own corporate emissions. And I'll just tell you a little bit about our corporate emissions. Our corporate emissions in 2018 were 12,000 tons. We are in the second round of our provincially mandated corporate energy management plan. The results that we reported were $6 million of cumulative utilities avoided from the projects, $2 million per year of utilities saved from projects we've deployed, $1.2 million of incentives gained and deployed, and that results in about a 14% per capita GHG reduction. And I'd like to recognize Amanda Martin, who is our corporate energy manager and the author of the two plans, that is with us today. So if there are any really difficult questions that I'll struggle with, Amanda will step in and help me. But she's been leading our program with a short break, and now back with us for about a year, and was with us about 6 years previous to that. We have 2.1 megawatts of rooftop solar, and we use that revenue of $300,000 a year to fund a lot of these projects. It goes into a revolving fund. We've integrated sustainability into our annual corporate report, and we've collected a couple of awards: Canada's Greenest Employer in 2018, Energy Manager of the Year for Most Innovative Project. That was Amanda Martin who won that. Very proud of her on that one. And then we're on milestones 3 for both corporate and community from our friends at FCM. couple of photos of our two of our 10 rooftop arrays of solar. How we do this, and Amanda leads a team of 3 people. We have a BAS specialist and an energy analyst on that team. And we take a service provision approach. So we will work with our facility operators, and we have a hybrid approach. My team in sustainability and asset management, energy is one side of it, but we also have facility operations for our admin buildings. Other groups, recreation, run their own buildings. So we have to work with a lot of different bodies. So we provide support, and we start with our life cycle. That's the beginning of the year, and we use that as a training basis for what we can do, what's available, what are you planning, what's up for renewal. Anastasia mentioned that their boiler was up for renewal, and they managed to get a study in there beforehand. We try to do the same thing. We try to be 2 steps ahead so that the study is coming before the boiler is up for renewal or the piece of equipment is up for renewal. We look at the options. We do the business cases, ROI, simple payback. We'll look at, for larger projects, we'll look a few years further out so that we can do a large scale study and complete those studies, get the audits done. What are the recommissioning opportunities? What can we do to make this building better with the dollars that we've got allocated from our life cycle? And then what additional dollars might be needed to get us to a better position to increase our savings? And what are the incentives that are available for us to leverage as well? And we'll put all of this information into our capital budget process. In fact, tomorrow we start our capital budget process. Further, what we're going to do is we're going to look at scopes and studies. So we're going to, Amanda and her team will write some of the scopes, some of the studies to provide the assistance to those facility operators that are living. We're going to help with contractors. We can do a turnkey delivery if necessary, and then also make sure that we get the incentives, that we verify the incentives, and that we follow up that the system is performing as expected. We'll do the building automation design and maintenance specifications as necessary. And like I said, we'll get additional funding from our own in-house revolving fund, Markham Energy Conservation Office. Provide advice and support and jokes throughout the project, and then monitor and verify that, and help with the staff report. So whatever's needed to help our facility operators improve their energy efficiency, Amanda and her team can deliver. So just, now I want to establish our credibility, how we do these things. I'll dive into retro and recommissioning because that's the topic of today's discussion. So what we'll do is we'll do it on 2 different aspects. One is, the building's not running well. We're having problems like Ian had mentioned. We're going to recommission the building. Others, we have an upgrade in mind. We have a BAS replacement in mind. We want to recommission at the same time. So we'll couple it. We can deploy it 2 different ways. But on the discrete approach is that we'll look at it as needed, and it'll be based on energy use or problems running in the building, too cold, too hot, unexplained energy consumption that we're seeing in our monitoring systems, occupant comfort complaints, those kinds of things. And, Ian had mentioned it, I think, really well, that buildings drift. Operators come and go. They make changes that they think are going to improve things, but they make it worse sometimes, or they make it better, or they turn it off, or what was in auto is now in manual mode and doesn't go back. So, things get out of tune over time, and you do need to get that retuning. On a larger project, what we're going to do is we're going to look at, particularly when we do building automation, because building automation connects into all of the components in the building. It's the brains, it does the programming, it tells them when to run. So when we're doing that and replacing that system, that central nervous system, we're going to use that as a recommissioning opportunity, because you don't want to put it in and then have everything run badly. You want to put it in and have it run really well. Run as it was intended, or as the designers have updated the system, because if you've changed other components in the building. And apologies if I'm speaking too fast for our interpreter friends. We'll perform a comprehensive major recommissioning study prior to the building automation or the BAS replacement. We're going to incorporate those recommendations in our scope. And then we're going to do our final commissioning post-BAS installation and complete our monitoring and verification. And I have 2 examples of how those savings have vested for us as a city. So we did a discrete recommissioning project for one of our community centers. Cost us $36,000. We leveraged incentives of $9,000 from our utilities. So our net cost was $27K. Estimated cost savings, and this is great because you see like less than a quarter of your payback. Estimated cost savings or verified cost savings, actually, because they have to be submitted with the utility incentives, $120,000 a year. And you can see really what the difference is on the curves. They're cleaner and they're significantly lower. So the blue is what it was the year prior, and then the red is what it is the year post the recommissioning. And you can see that we've been able to drive down the peaks, and then we've also been able to drive down the off-peak energy demand as well. So that's a really good example of how a discrete recommissioning can save you money right off the bat and have a very, very quick payback, as Anastasia identified as well. On a larger one where we built it into a BAS project, and this is for our Milliken Mills project. And this is actually the one that won the Energy Manager of the Year award because they piled in so much and built in the recommissioning with the building automation system. You can see that we've been able, on a heating degree day and cooling degree day, ice adjusted, we've been able to drive down the energy consumption significantly. And so this one cost us $125,000 net. Savings are about $65K a year, a 21% energy reduction, and our simple payback is 1.9 years, so less than 2 years of savings, coupled in with a bunch of other retrofits. And of course, optimized staff savings, cost savings, regular recommissioning. We're doing this throughout the life cycle as needed, because it's a tool that we've got in our toolbox now. So looking forward, and Mark, and what we're looking for is we're going to continue building staff capacity, literacy, and capabilities. And that's something that Amanda and her team are very focused on, because the more friends you have, the more people that know what to do, who to go to get help on these projects, the more successful you're likely to be. This is not something that we're able to deliver on our own. We do it as part of a team. We're going to expand our focus to GHG emissions. We were largely focused on electricity reductions, electricity utility reductions, because of the structure of the funding that we had. We're going to go for GHG emissions, and we're going to really look at what it's going to be, the impacts to us for carbon pricing as the carbon pollution fee or tax from the federal government ramps up to $170 a ton. And so we're building that into our business cases now. In fact, tomorrow and just today, I've been working on a presentation to seek funding from our council for our capital budget process for a large retrofit and 2 or 3 studies for reducing GHG emissions in our large community centers. We're going to continue to reevaluate our green building standards and performance metrics. So we have some internal standards that we apply for new construction and retrofits. And then we're going to work on our monitoring and verification, and that's going to happen because we've added in the energy analyst position, and we're really hoping for some great outcomes from that person. And so that's all I've got for you. I hope I'm catching us back up on time. I know my other speakers were actually doing pretty well as well. So thank you. Looking forward to questions.
Yes, absolutely. Well done, Graham, on time. I didn't have to use my sound signal. I'm always disappointed.
I didn't hear the beep, so are okay.
No, right on time. And thank you very much for your presentation. And we all know that Markham is well known across the country as being a champion when it comes to climate action. So it was great to hear you share your perspective on recommissioning as well. Thank you. And now we're moving to our last speaker. So let me introduce Meg Sears, who is a senior research associate at the Ottawa Hospital Research Institute. So Meg, over to you.
Thank you very much. We'll get this rolling here. And okay, I need to be firmer with my touchpad, I guess. Thank you very much for this opportunity. This is tremendous. I'm honored and grateful to be joining you today from the traditional unceded territory of the Algonquin Anishinaabe people. I'm speaking on behalf of the Canadian Committee on Indoor Air Quality and adding in some of my own knowledge on this material. The CCIQ is a balanced volunteer, expert, multi-stakeholder national committee that includes health and science and engineering, industry representatives in practice and in academia. I've worked with them for several years now, and it's been an honor and very intellectually invigorating. So the CCIQ aims to improve awareness and measures for indoor air quality and ultimately to protect occupants' health. It's funded and administered at arm's length by the National Research Council. We synthesize up-to-date scientific information and practices in public health and engineering and develop best of knowledge modules in the Canadian context. So these modules are for key stakeholders, such as facility managers and lay audiences, but the CCIQ does not set standards or codes. So it's no news. Today, we're facing two global emergencies, the climate related to energy use. And then in the middle of it, we have COVID-19. And the last thing we want to do is to worsen one while addressing the other. So as we discuss COVID-19 in buildings, we also consider strategies to minimize energy use. So today we're giving you some food for thought to recognize opportunities while recommissioning buildings. Addressing COVID-19 in buildings was first published in August of 2020, and we're very pleased that it was actually cited by the European CDC. You can see that in this first update in June 2021, we cover many topics. It was thoroughly reviewed by the CCIAQ as well as many external experts. It includes more than 250 peer-reviewed authoritative references, as well as useful resources and modeling of COVID-19 transmission risk. So of course, global emergencies are evolving topics and research is ongoing. Just so we're all on the same page here, COVID-19 infection develops when the virus SARS-CoV-2 reaches mucous membranes in the mouth, the nose, the throat, and perhaps the eyes. Masks are the first and last lines of defense against airborne contagion. Transfer from surfaces to the hands and then to the mouth and nose are possible. And resuspension of floor dust that contains virus is also possible. But rule number one is to stop the contagion at its source. So a mask slows down and captures virus that's exhaled by an infectious person on the left. The biggest droplets that would otherwise fall to the floor are captured, and depending upon the quality and the fit, a mask captures some or close to all of the smaller aerosols. And these microscopic virus-laden particles can otherwise stay airborne for hours. They can be inhaled, especially by susceptible individuals. That's our concern. We all know, first reduce this risk, the release of infectious particles. So stay home when sick, wear a mask indoors in public, because we could be infectious without symptoms, even if you're vaccinated. Secondly, recognizing that when the infection is in the community, it may well be in the indoor air. So how do we minimize the risk of breathing in an infectious dose of SARS-CoV-2? There are many possible measures indoors to supplement wearing a mask, and we need to use every tool at our disposal. More layers of protection include physical distancing, limiting occupancy numbers, occupancy time, replacing potentially contaminated air with clean air, with ventilation and open windows and doors, disinfecting the air with air cleaners and ultraviolet fixtures, and of course, all of the public health and medical measures that are available. So every building is unique. I wish I could give you all a perfect solution to this, and I can't. It is going to require a mental exercise by everybody addressing particular buildings, particular rooms, particular situations. There's no one size fits all, and as buildings are recommissioned, there are probably opportunities to reduce airborne viruses where it matters in the breathing zone. For example, consider where occupants might be protected by clean airflow or might put others at risk if an individual is infectious. The University of California at Berkeley discusses many scenarios, and these thought exercises may give you ideas to apply in your facilities. course, modern Canadian buildings usually have some sort of HVAC system that maximizes mixing of the air, and pollutants or contagion are continuously diluted with outdoor or cleaned air. Now, energy recovery is important in the Canadian climate, and advice is evolving as to optimum strategies. The American Society of Heating, Refrigerating, and Air Conditioning Engineers offers extensive advice regarding refurbishment, maintenance, and running to maximize clean air delivery, or CADR. With airborne viruses, we want to exhaust, we want to exhaust the the areas where the contagion may be higher, such as bathrooms, and areas with heavier, deeper breathing, such as music or exercise rooms or crowded areas. I mentioned that we did a bit of modeling. So last spring, while we were working on our update, the Alpha variant was clearly becoming a problem. So we wondered, how much better do we have to use all of our tools to avoid increasing COVID cases? How much better do masks and ventilation and so on have to be? To get an indication of scales of concerns, this work was led by Dr. Leon Wang at Concordia. The module includes many analyses using a basic mixed air model, applied in this case to a schoolroom. Here are results with one infectious person among 19, showing how ventilation rate on the vertical axis and mask efficiency on the horizontal axis work together to reduce transmission. Now, the goal is to keep what the epidemiologists call R0 less than 1, and that's up in the upper right realms of the graph. This means that one infectious person on average infects less than one person, and under those conditions, the pandemic just fizzles. So this figure goes up to very high ventilation rates, but at a typical ventilation rate of 2 air changes an hour in schools, masks had to be more than 45% efficient with the original SARS-CoV-2 and more than 65% efficient to maintain similar rates of transmission with the Alpha variant. A person infected with Delta produces many more viruses in their nose and throat, so even higher efficiency masks are needed. Greater ventilation is needed. Now, masks have improved a lot during the pandemic, and more comfortable, better fitting, higher efficiency ones are available. And of course, vaccinated people are protected against severe disease, but may still have a period of infectiousness, sometimes without symptoms. So everyone must wear a high quality mask properly indoors in public buildings when the virus is circulating in the community. The details of this modeling will change for different situations, but the trends are universal for occupied indoor spaces. We included a large selection of analyses in Module 15, and the spreadsheet is online. So if you're inclined to play with spreadsheets, you're more than welcome to download it and explore scenarios for rooms in your buildings. Now, particularly in winter in Canada, we cannot count only on the high volume ventilation for dilution of virus. We also need to clean the air with filtration or otherwise disabling the virus. Multiple portable air purifiers spread throughout a room can be more effective than single units and may be run at lower speeds for quieter operation. Now, here is a popular DIY solution. These box fan boxes can produce about 400 cubic feet per minute of clean air delivery. They're made with 20-inch box fans and 20-inch by 20-inch furnace filters, plus duct tape. Canadian icon Red Green would be proud. Just a minute, let's see if this will work. Oh, this is strange. I apologize for this. There we go. For some reason, it didn't want to display that properly. But air disinfection using ultraviolet light is also a possibility. ultraviolet will disable the SARS-CoV-2 very quickly, but it must be shielded from sight because it will otherwise damage your eyes. UV lights may be mounted in ducts high on walls. They may be mounted along with ceiling fans and are sometimes incorporated in standalone air cleaners. It's important to know that since some UV air cleaners can produce ozone, which also damages eyes and airways, these are now regulated by Health Canada. This is a recent requirement and it's a little bit in flux right now. So nevertheless, you should be asking your vendors for evidence that this equipment is approved, or at least that they're in communication with Health Canada. I would also note that electrostatic air cleaners can also produce ozone, so they're not as desirable. As well, there are no fogging chemicals that are approved for airborne infection control in Canada. And the link is there to the Health Canada announcement about this regulation of the air cleaners. So you can imagine there's a lot of people saying this is a lot of ventilation. How much ventilation is going to be enough? And we can't really put a hard number on that, unfortunately. Generally, more is better. Pollutants or contagions are continuously diluted with the ventilation air, and in module 14 on indoor environmental quality, we examined productivity at work and achievement at schools, and researching green office buildings finds that lower absenteeism and higher productivity with greater indoor air quality mean that on monetary terms, it actually can make very good sense to have higher ventilation rates and better indoor air quality. But in 2021, we asked, what about the energy? What about the carbon dioxide? And with COVID, we also asked who was downwind. So maybe we can reframe things and start thinking about another ventilation scenario. The virus is a worry if it's breathed in, but I'm not so worried about the virus that's on the ceiling. There's a lot of interest in moving the virus out of the breathing zone and having effective ventilation. Now, displacement ventilation is an alternative strategy that avoids vigorous mixing of air and relies upon stratification. The cool air enters low in the room, rises as it's heated by occupants, taking virus aerosols with it, and is exhausted at the ceiling. This is being applied widely in makeshift and standard healthcare, and it's in some large facilities. These authors compared standard mixed ventilation to a bath where the water is automatically contaminated versus displacement ventilation being like a shower where the water is continuously cleaned. And this has actually been successfully implemented in industry. It's more common. In this example, we have a machining shop. And cool air enters through diffusers close to the floor. Infrared heating of the workers and equipment ensures that plumes of warm air rise to the exhaust ducts in the ceiling. And this study reported that the workers were well protected from the very fine aerosols of used machining oil. Now, when CO2 is emitted only by the people, then it tracks breathed air and is maybe associated with virus. That's if there is no air cleaning. So there are many caveats to the interest that we've been seeing with carbon dioxide monitoring. But as long as we just have ventilation, no air cleaning, and all of these other caveats are met, we see ranges of recommendations 100 to 400 parts per million. And we also want to be concerned about thermal comfort because that poses a potential opportunity for energy savings. The perception of temperature depends more than what just the temperature, what the thermometer shows. And there's good research that we also reported in module 14 that we can successfully trend the indoor with the outdoor temperatures using a broader range of temperatures over the seasons, and perhaps even supplement with IR heating again. So IR heating looks to be a very interesting thing to start looking at. And after all, who's worn a sweater indoors in the summer or a t-shirt in an overheated building during the winter? And we just can't afford to do that anymore. So I can't talk about COVID without saying we still have to wash our hands and clean our facility for the sake of indoor air quality and public health. Use unscented soap and water. Pay extra attention to the washrooms. And if you need to disinfect, then protect the lungs by using, again, fragrance-free, zero VOCs and oxygen-based disinfectants. But SARS-CoV-2 is rapidly inactivated by soap. And so that can be our top choice. So I have to thank you very much. We hope this is good food for thought as we adapt to living with the SARS-CoV-2 virus. The Canadian Committee on Indoor Air Quality wants to help you, welcomes your involvement. So please send your questions, observations, and so on through our website. And thank you. Be kind and be safe.
Thank you, Meg. That was very well said. Be kind and be safe. I like it. I'm going to steal it from you. So thank you. It's great insight.
You're welcome. I've stolen it from many people who are better than me.
Oh, there you go. Then it's mine. It all started with me. So yeah, this was great insight. Thank you very much. We all know that COVID has really changed the landscape when it comes to energy and efficiency measures, and it's quite uplifting to hear that there is solutions and that we can kind of responsibly address both these important issues. So thank you very much for your presentation. So now that our speakers have definitely convinced you of the importance of building recommissioning, I'm happy to share that FCM offers funding solutions to support municipalities who are looking to recommission their community buildings through our Community Buildings Retrofit Initiative, or how we like to call it, CBR. So CBR is a $167 million initiative and is funded by the Government of Canada. Its mission is to support municipalities and their partner in achieving triple bottom line benefits through the retrofitting of buildings that are heavily used by community members. And I'm going to take just a small break here to give a chance to my dear colleague Sharon to share my presentation with you guys. Or I'll continue, and don't worry, the presentation will be available online, so you don't have to rush to note all the information that I'm giving you. So basically with CBR, what we're looking at is really to reduce the GHG emissions in large community buildings and to lower operating costs, creating local jobs, and improving building quality while supporting community use. So this program is really designed to be stackable with other funding programs, including those available in your provinces and territories. So maybe just a quick note that by community buildings, we're referring to buildings that are primarily used to provide athletic, recreational, cultural, and community programming and services to the local community. So this thing normally includes some of the biggest energy users in most municipal buildings portfolio, such as community and recreational centers, sports arena, indoor ice rinks, swimming pools, art centers, auditorium, and libraries. So it gives you a bit of an idea. So what we want to do is to offer municipalities support all along their journey to optimize the performance of their existing community building, and no matter where they are at. So we want to help municipalities to understand their building performance, to optimize their existing building systems, to study long-term retrofit options, and to implement capital upgrades. I'm just gonna give a second. I'm glad to see that the presentation is up now. If we can advance it, maybe just 2 slides to give people the opportunity to, yes, to see this wonderful slide. So here we are, understanding the building performance, optimizing the existing building system, study long-term retrofit options, and implement capital upgrades. So you see, it's really the whole continuum. So to do so, we have 5 different funding options. So today I really give you a bit more of information about the recommissioning grant, of course, but just I want you to know that there's more, and that I'm here to provide more information about the other options of funding as well. So if you don't mind switching the slide, please. We offer grants for building energy monitoring and analysis, for building recommissioning, of course, and to complete GHG reduction feasibility study. And Graham, I noted that you're going to apply for that one. I'm sure it's us. I'm glad. So we'll talk. And we also offer loans and grants for short and long-term capital projects. So these are all options that are available. So in terms of support for community building recommissioning, GMF provides funding to assess how existing equipment and systems are operating, and identify simple ways to improve and maintain performance, and address issues and implement low-cost fixes. If I could trouble you to switch the slide, please. This always happens. It's a nightmare for producers. Thank you so much for your work, Sharon. It's always a bit of a struggle. So I'll just continue along, folks. Like I said, this presentation is going to be available after, and this is all information that you can have by reaching out to me, or that is available on the internet. So basically, with the recommissioning grant, what we offer is to cover up to 60% of project cost to a maximum of $55,000. So projects usually include 4 phases: the planning, investigation, implementation, and handoff. And over the course of these phases, building owners define the scope of work, find and prioritize opportunities for improvement, implement these improvements, and develop a strategy to maintain the building performance over time. So we expect most projects will focus on a single building, but projects that include multiple buildings are also eligible. So you can come with a portfolio. Maybe a quick note that we will accept only 1 community building recommissioning project per individual municipality. So that's regardless of whether the building is owned by the municipality or a not-for-profit organization. So to give you an example, this means that if a not-for-profit organization from, let's say, the city of Saskatoon submitted an application and was approved for funding, then the city of Saskatoon itself would not be eligible to apply for the recommissioning grant. So for this reason, we ask any municipal partners, like a not-for-profit organization, to demonstrate that they have the support of the municipality to go ahead with an application. So I know at this point you're all wondering how to apply. So the good news is that all the information on how to apply is available on our website at fcm.ca/community buildings retrofit. I think that we can post that link into the chat. So fcm.ca/community buildings retrofit. And you can access directly the application guides, form, and project workbook for the recommissioning grant. It's a bit different for capital project and studies, but for the recommissioning grant, it's fairly straightforward. You have all the information you need directly on the website. Of course, you can always contact me or my colleagues in outreach. This is why we're here. We like to say that we offer a concierge service. So please come to us and we will guide you through our funding options, as well as the application process. And I think that I will also share my email address in the chat. So I look forward to speaking with you all. So without further ado, and last but not least, we will move to the Q&A session and the last portion of our webinar today. So to do this, I would like to introduce my colleague, Matthew Yarman, who is the energy modeling specialist here at FCM and who will be moderating the Q&A.
Hi, everybody, can you hear me?
I can hear you.
We got you? Okay, great. So we have a few questions. One came in from Leon for Ian, if you're available. Question is, what is your current building commissioning objective during COVID? Is it to meet the original design parameters of the building, or is it to meet the COVID recommendations? He's talking about ventilation rates. Maybe the goal is to save energy, but because of COVID, you're increasing ventilation rates, so you might not actually save energy. might do the opposite. So basically, how does COVID impact your commissioning objective?
Actually, I responded to Leon sort of individually, but
Oh.
no worries. I'm sure lots of others are this. And in fact, in my presentation, I mentioned that typically an existing building commission is done to restore the building kind of to its original design intent. But that another reason for doing that is that your original design intent might actually change. And so actually, in the case of existing building commissioning, I should have mentioned that what it's really done is to optimize the building to its current facility requirements, or CFR, which is a term that's used in the profession. And this is a great example. And I thanked Leon individually, and thank him now publicly for bringing up this example. That, coming out of COVID like this is no better time to think about this, because your operating regimes of many of your facilities is going to change. Because as Meg touched on extensively, that you're probably looking at changing how you're operating your HVAC to make sure that the air that's being distributed around the building is, does guarantee that it's healthier and safer. And you may be implementing some of the technologies that she talked about to make sure that kind of thing happens. So that's a perfect example of changing your facility requirements, which indeed is a good trigger to do an existing building commissioning.
Great, thanks very much, Ian. A question for Graham.
Not a question from me, but can I compliment Ian's answer there?
For sure.
Absolutely.
Okay, so we're implementing what we're calling pandemic mode in our BAS systems, which is driving the systems to run longer and with full open fresh air makeup. We've also increased the filtration medium from probably a lower level MERV to MERV 13. We haven't gone to HEPA because the use on the fan motors would be quite significant. But in seeking authorities and reporting this, we are letting our council know that we're anticipating increased energy consumption from the longer run times and from the increased amount of fresh air, particularly when it's really cold or really hot, when the deltas are big.
Right. Yeah, that's good to know. Yeah, I'm sure everything is changing. The COVID changes a lot in ventilation rates. You're having to heat up that air in the winter, for example, if you're bringing in more fresh air. Good points.
Leon, you can write to Amanda Martin, and she can help you with that question on the data that you just asked in the chat, please.
Great. Actually, I'll just throw another interesting commissioning point that I've a commissioning professional was lamenting to me about this, and I think I'll pass it on because I think it's quite relevant to this particular discussion. Meg had mentioned that the options that buildings are looking at is using like UV lights in the right places to actually disinfect the air, and that's something they experimented with. My commissioning friend was mentioning to me that he was working with a building owner who had put the UV filters on the incoming air into the building. And that's completely the wrong thing to do. And this is one of the things commissioning people do. They look at these things and say, look, this is a good idea in the wrong place. It says, no, you apply the UV filters on the air exiting, or before it's being recirculated is when you do that. Otherwise, you're just wasting time and money and energy. So it's really important when you're doing these, post-COVID upgrades to really make sure that you're implementing them in the correct way. And again, a commissioning professional is someone who might be able to help advise, not the only person who could advise, but certainly someone who can help advise doing that the right way.
Great. Maybe Meg wants to chime in here. You're talking about having to increase the ventilation rates in some buildings as one way to help reduce the risk of COVID transmission. What have you seen in terms of your ventilation rates increasing from and to in typical buildings? Do you have any examples you could share with us?
Actually, my employment is not in buildings. I'm a scientific writer.
Oh, okay.
So I would suggest that you ask the committee that, because there are people on the committee who could probably answer that more fulsomely. What they're talking about is, our modeling shows that if you are going to use poor quality masks, you see what you're trying to do is to stop people from inhaling the virus. And a mask, a very, very good mask, can take care of it, and you don't have to worry about it because you're not going to have the virus going into the air, and you won't have to worry so much about it, getting back into somebody else's nose. But so all of the modeling has to consider the ventilation, the occupancy, the time that people are going to spend in this space. And but nevertheless, we need to go substantially beyond the ASHRAE recommendations that are really just to control bioeffluents and carbon dioxide. So we did look at that pretty extensively in module 14 before COVID, and we found, just from the point of view of productivity and success in schools and so on, we can have much better production of whatever people are supposed to be doing in these large facilities with much better air quality. So on that basis, people are looking at 2 or 3 or sometimes even 4 times. So that gets pretty breezy, and that's a lot of energy. This is why we're talking now about, instead of trying to mix it all and have the bathtub analogy, we think that it would be more efficient if we can somehow use to some extent the infrared heaters, so that we get that plume of rising air and take the virus out of the breathing zone.
Great, thanks very much. We did have one more question for you, Meg. Someone has asked, how efficient is a typical cloth mask?
Well, actually, in the module we have a section on masks, and it can vary tremendously. A mask worn under the nose is very ineffective. A mask worn over the nose is much more effective. There are now designs for cloth masks that are up to 90% effective, which is comparable to what you wear in healthcare. And it also just depends upon the materials, the number of layers, and so on. So there's no simple number.
There's no one answer, yeah.
No, there's no one answer, but we do actually have quite a bit about that in the module. So I recommend that they have a look at that.
Check that out.
Yes, yeah.
Great, thank you. So quick question for Graham here. You shared a recommissioning project that cost $36,000 and saved, I think it was $120,000 a year in energy cost and 12% energy. Just curious about what changes were made in the commissioning to save this amount of energy.
Can I call on Amanda Martin to help me with that one?
Yep.
And just for context, I'm lucky to lead a team of 30 people, so I can't get into the details. Okay. As much as the specialist experts on the team. So I know Amanda can respond to that appropriately.
Yeah, thanks. So it was a number of improvements, including some of the ventilation equipment was operating 24/7, and part of the recommissioning exercise was shutting the equipment off overnight in areas that didn't require ventilation overnight. Also during unoccupied times during the day, we were shutting off ventilation, optimizing heating and cooling temperatures. We rebalanced the hydronic system that supplied district hot water throughout the facility. So I guess also optimized fresh air, which might be undone now with this pandemic mode. So it was a number of improvements, and yeah, most of them involved working with our building automation system service providers to fine tune the controls and schedules, temperature set points, all of the typical operating parameters. Anything that was an operator override, we reset back to normal schedules and train the staff.
Great, thanks for that information. Yeah, sounds like
Thanks, Amanda.
a lot of small changes made a big difference. One last question, if Anastasia is still here. When you had an energy audit completed to predict how much energy you would save from lights and just ceiling replacement, even a low emissivity coating on the ceiling or layer, how closely did the actual savings match predicted energy savings? I don't know if you have that information, but.
Yeah, that's a great question, and it's something we'd love to be able to track very precisely. But I think because of COVID and some closures that happened and our upgrades kind of coincided with it, it's really hard for us to say what's attributed to what at this point. But yeah, so now that things are normalizing a bit more, we'll be able to make more of a apples to apples.
Right,
So,
I guess, yeah. When the building occupancy patterns changes, the building's closed after you did the retrofit, you can't really compare before and after when the building may have been closed for months, for example. So
yeah, but the graphs that I've showed you with those significant reductions, that's over the last 12 months when things have normalized a bit. So we're definitely seeing a big dip in the energy use.
Great, thank you. You know what, that's all we have for questions, unless anyone has a last one they want to ask. I think we're done for the Q&A.
Thank you very much, Matthew. And thank you again to all our speakers for joining us today and for sharing their expertise on this subject. So we really appreciate it. This wraps the presentation portion for today. The one last thing that we will ask, please, is that you take a moment to complete our post-webinar survey and just share your thoughts on today's presentation. I just also want to highlight that you see now on the screen the contact information, gmfinfo@fcm.ca, donc gmfinfo@fcm.ca, donc ainsi que le numéro de téléphone, as well as the phone number, so you can please reach out if you have any additional question or if you're interested in our funding solutions. You can also have a look at the website that you see at the moment as well. So again, thank you very much all for joining, and we'll see you for our next webinar.